In this question, we're told that a jet of water flows smoothly around a curved vein, which turns it through 60 degrees. We're told the initial jet is 50 millimeters in diameter and has a velocity of 36 meters per second. And as a result of friction, the water leaving the surface is 30 meters per second. So in the lecture, I sort of said if we're ignoring friction effects, the inlet and outlet velocities will be the same. But clearly in this question, we're told to include friction, but it doesn't matter because we're told what the exit velocity is. And we're asked to calculate the magnitude and direction of the resultant force exerted by the water on the vein. So it's always good to draw a diagram of to visualize what's happening. So we don't know what orientation this vein is actually in, but we know that it's being the water's being turned through 60 degrees. So best to set our inlet being completely horizontal to make the maths easier. So set up our coordinate system. Our inlet's coming in horizontally and the water's being turned through 60 degrees. So we can work out the components of the velocity that's leaving the the components of the velocity in the outlet jet. So if we know this being turned through 60 degrees, we can see that the x component of the velocity is the velocity x tin times cos 60 degrees, and in the y direction it's sine 60 degrees. Okay, so these are the x and y components that we need for the next part of the question. So the momentum forces are, so in the x direction we have the mass flow rate times the x component velocity for the outlet jets minus the mass flow rate times the x component velocity for the inlet jets, and the same for the y component. So if we go through and work out what each of these components are, so for the inlet jet is perfectly horizontal, so the Cx is equal to the inlet velocity, which is equal to 36 meters per second, and because it's perfectly horizontal, there is no y component velocity, therefore that's equal to 0. Now for the outlet, as we showed on the previous slide, we can work out what this x and y component velocities are from trigonometry. So for the x component it's c2, which is 30 meters per second. Remember, we were told that in the question. It slows down due to gravity. It slows down due to friction. So it's 30 meters per second times cos 60, which gives us 15 meters per second, and in the y component it's sine 60, which gives us around 26 meters per second. So we have all the components of velocity there. So we just need to work out the mass flow rate to be able to solve this. And one thing, even though we do have friction in here, we do know from continuity that what goes in must come out. So the mass flow rate has to be the same. So mass flow is equal to density times area times velocity. So we're told it's water, so we know density is 1000. We're told to down to the jet. And we can use the inlet velocity because we know the inlet area, we don't know the outlet area, obviously that would change. And that gives us a mass flow rate of 70.69 kilograms per second. So if we plug this mass flow rate along with each of the velocities that we worked out into these equations, so for the x direction, we end up with the force acting on the fluid in the x direction is minus 1,484 newtons. So this is the equation, this is a simplified version, and then this is with the values plugged in. Then in the y direction, here it is, remembering that the y in is equal to 0, so therefore the force acting on the fluid in the y direction is plus 1,837 newtons. So these are the forces that are acting on the fluid. So just bear in mind, these are the forces acting on the fluid in the x and y components, but we were asked to find the force, the reaction force on the vein, and those will be equal and opposite to the forces that are acting on the fluid. So therefore the force acting on the vein will be plus 1,484, and in the y direction it's minus 1,837 newtons. We're also asked to find the direction, and now we have the x and y components of the reaction forces. we can again use trigonometry to find what the reaction force is. So we know the reaction force in the x direction, we know the reaction force in the y direction. It's downwards because it's negative here, and positive left to right as per our coordinate system. So using Pythagoras, we can find the force acting on the vane. So squaring each side of the triangle, and then square rooting gives us the magnitude of this vector, which is the force on the vane. And then we can work out the direction again from trigonometry. If we know the length of each side of this triangle, we can find out the angle by taking the inverse cosine. So we get the force is 2,360 newtons, and it's acting an angle 51 degrees below the horizontal.